Hey everybody, back again for day 4 of Advent Code 2025. Hope you're doing okay. It's just a few days before Christmas. If you celebrate, I hope you're having a nice build up to the festive season. I'm plugging away, going to do the puzzles as and when I can, just not going to give up, just going to keep at it as long as it takes. Last time we did the second part of day 3, so I'm just going to have a go, I think, at part 1 of day 4, unless it's super easy, and and then we'll carry on and do the second part. I've switched. I did use, I think, Zed as my editor in one of my previous videos. I'm giving it a go again. Yeah, let's see how we get on with it today. Yeah. So let's get into it. So return to your Advent calendar. 6 gold stars already, look. And then here we are on to day 4. Printing department. You ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere, and there's even a massive printer in the corner. Handle the really big print jobs. Right, okay. Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that. One of the elves replies when you ask for help. We're pretty sure there's a cafeteria on the other side of the back wall. Okay, if we could break through the wall, you'd be able to keep moving. It's too bad all of the forklifts are so busy moving those big rolls of paper around. Okay, if you can optimize the work of the forklifts, if you can optimize the work the forklifts are doing, maybe they would have time to spare to break through the wall. Okay. The rolls of paper, so this is a roll of paper, nice, are arranged on a large grid, okay. And the elves even have a helpful diagram, your puzzle input indicating where everything is located. For example, so we've got an example here, I see, right, so I guess this is like a palette or something. Grid. So we'll stick that in here as our input for our test, and I'm sure it will tell us what we're expecting. The fork, yeah, okay, 13. So let's pop that in there before we forget. 13. Okay. Right, so the forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. Fewer than 4 rolls of paper. Oh, all right. Is this kind of like the idea of the forklift can't get to like the ones on the inside or something, because so the dots are a space, get that, and these are rolls of paper. Right, okay, so what it's saying is, and I'm not going to be able to highlight it, but we need to have a look for we need to look at each of these rolls of paper, and then we need to look at the 8, yes, it would be 8, wouldn't it? The 8 positions or locations or around that roll of paper to see whether there are fewer than 4 rolls of paper in the 8 adjacent. Yeah, okay, that makes sense. I think I get it. In this example, there are 13 rolls of paper that can be accessed by the forklift. Okay, consider the complete diagram of paper locations. How many? Right, get the puzzle input. There's a lot of rolls of paper. So we'll copy all of that, and yeah, I'm not too good with all the shortcuts yet in Z, but we'll go with that, and we'll go back to part 1, and we will. I'm going to be picking up the mouse a bit today. That's okay. Right, so we've got a test input and we've got our test set up. So if I just return 13 here, I think there's a way of popping up the terminal. Yes, and then we can run cargo test dash package day 4 this time dash bin part 1. Okay, yes, my input is not being used. Yep, okay, so that's fine. So if I do that, and then, getting a bit muddled here, but yeah, let's try again. Yep, okay, right, okay, as we'd expect. Right, so how on earth are we gonna... I think I can close that. So I think I need a grid, something called a grid. I don't think I'm going to try and figure this out sort of just kind of like, so I've been looking, looking at the solutions or the puzzles that I've done so far, and the solutions have been very kind of like literal. I've been sort of just splitting the string and looking in different places. So kind of like very, very sort of simple approach, I think, to the puzzle. So I think I'm going to try and keep that very simple approach going. So what I'm thinking is I want a grid. And I want to... I think I'm going to use a hash map, because then because with a hash map you can create an arbitrary like key. So I'll have so I think what I'll do is I'll read all these into a hash map with X and Y as the key and the value. So I have a grid and I have my paper rolls, and then I can all I need to do, then I need to look through the hash map for the roles, and then I can, if I've got the X and Y, I need the X and Y obviously, because I need to be able to check the 8 locations around it. I'm not too worried about the, like on the edges here. I'm guessing that like this is like like a dot here and a dot here. So, like the board, so this is all dots effectively round there. So I think with a hash map, I can do like get, and that will give me, this is where my memory is so terrible. So what I'm thinking is if I do a hash map, and then this has a method. Yeah, it gives you an option. So it returns a reference to the value of the corresponding key. But if the key doesn't exist, then you get a none. So I can do, and then with that I can do that. So if it's none, or it is, see, I'm thinking of actually like getting the dots, because that's, I think, fewer than 4. Because really what I'm interested in is, it doesn't matter, does it? I think I'll go with Oh, I don't know. That's just to see. I think I've got a basic idea. So a grid with which is a hash map with the key being tuple X and Y, and then the actual character. And then we can do maybe even write a separate function for passing, like, yeah, maybe passing like the current XY. If it's a roll of paper, pass that in with the grid to see whether it's, yeah. I'm losing myself a little bit. So let's start with the simple stuff. Let's get right. So I think I want to know what. I think the first thing I want to do is to get the grid and call it dimensions. Okay, so let's get going. Dimensions. Let grid dimensions equals, and then it will be input. And I'm going to. So what I could do is use iterator over lines and count them to get the kind of like rows, and then I could take the first line. But what I might try and do, I'd take the first line and count the characters in it. But what I might do is, if I do input dot, let's go and get rid of that, and then input dot, yeah, this is kind of what I've been in. I mean, I've got this in Vim, but I have to kind of like pop it up with Control X and O. I could probably get this working in Vim as well, but this is quite nice in that it pops up the available methods on whatever it is you're typing in at that point in time. So find, what we're looking for is the end, the new line. So find that. So find gives us an option. So I think we can unwrap that. And this will need to be in this is a tuple I'm creating here, I think. And then here I want inputs dot matches, and I'm looking again for how many new lines there are, I think, and then I can count them. And then I'm going to take it step by step with my DBG stuff going on, so I can see what I've got. Okay, this might be a long video. I'm sorry, I just got the sense, but we could be here a little while. So what have we got here? Oh, we got 9 and 10. All right, okay. I guess we need to. I guess this is how many? So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, yeah, because there won't be one on the last one. So that makes sense. So if we just increment that there, then I think that's fine. So we'll get a 10 by 10 there. Pretty sure that's okay. And then we'll create a grid, which is a hash map. And that is brought that into scope. That's nice. And we'll do, I think, can we do with capacity? Yes, with capacity. And so what we'll do is our grid dimensions are a tuple of U size. So we can say that and then multiply. I think it's strict mul. Yeah, strict integer multiplication. And then the right-hand side will be our grid dimensions dot 1. So that should give us, so we're timesing the, yeah, so we've got 10 by 10. That's our grid, I think. Assuming these are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's right. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 100. Yeah, 100. Yeah. 10 times 10 is 100. Okay, right. So that's our grid. So now we need to fill the grid. So I'm not bothered about. So input dot. Input dot lines, and then I need to know. So I know you can use enumerate, because that gives you enumerate. It's an iterator which gives you the number of the iteration. So if I do enumerate on the lines, I'll get the line number I'm on, and if I do it on when I'm iterating over the cars in each line, I'll get the number of the character I'm on. So I'll get the Y and I'll get the X. Maybe. So this is a row. So I'm going to go with Y here. And then here I'm going to say, so Y dot, so yes, I've got a U size, which is the line number, which is the row I'm on. And then I've got a string at 1. So if I can go cars, yes, I can on there. And then enumerate on each of the characters in each line. And then I can map over that. And this will be my X. And then I can, here, I can say grid, and grid will need to be mutable, I guess. Grid insert. So here will be my tuple of X dot 0, which is a U size, and it needs to be an I32. So I just cast it to an I32. And then the same with Y0 as I32. And then my value is X dot 1, which is, X dot 1, which is my lots of unhappiness here. I think I might need to at least do some collecting, and probably some just into a vec. I should look into, because I know you can just drop, can't you? Search computer, and then can I just search for drop? Maybe I'm making this up. Some way I think of just like not collecting or something. I'll look that up afterwards. I don't want to make this a longer video than it's going to be. And I'll just do the things I know work, even though they're probably, why collect this? Oh yeah, grid needs to be mutable. I think that's what that's probably complaining about. Okay, and then problem here. Unused return value of collect, that must be used. We don't need to do that. There we go. Looks a bit happier. So here we should have a grid full of, we should have a hash map, our grid. So I'm going to print it out, dbg grid, and this should be filled with our X and Y tuple as the key, and our paper rolls or empty spaces on the grid, dots. So let's have a look at that. Down here, clear, and then okay. Oh, hold on. Not so fast. What's going on there? White space. So maybe we need to trim the string. Let's try that. Where are we? So if I wham a trim in there, type, and then try that again. Clear. Oh no, let's just run it and then have a look up. Oh, okay, dot, paper roll. It's not easy to read all this, but yeah, that's looking better, isn't it? I don't think I've seen any empty stuff yet. Okay, right, we'll call that good for now. Might find out later that it's not, but anyway. So we've got our grid, we've filled it with our stuff, and then what would be really nice here is we could say, we're gonna have to iterate over the grid. Iter, can we do iter? Yes, iter. And I think we want to fold here. Initial value in is 0, and then we'll say, and I think I'm gonna stick with my initial idea, which is to work out how many dots there are. Because if there's more than 4 dots, I'm good. And this kind of be like a bit easier, because like when I get a none, I can just assume that's a dot and I can count that as a dot rather than counting the paper rolls. I think there's a method in my madness, maybe. So this is a grid. I'm going to call this a square, I think. Not that it's a great, yeah, there's probably a better name for that. But yeah, we'll go with square for the moment. And then we'll say if square dot 1, because square dot 0 is the tuple key, square dot 1 is our actual character. If that equals paper roll, then we're interested. But we also need to check, we need to add something to this. So here we'll return dots plus 1, else we'll return dots. And then we can get rid of that there. What's going on here? Consider dereferencing here. Oh, okay. Yep. I'll cool with that. All right. And then what we're going to need to do, if dot equals that. So basically, I want to say is accessible. Is this paper roll accessible? And then in here, I will pass the square and I will pass the grid. And then I will let that function figure it out. So I want a function that returns a Boolean, basically, I think. Yes, of course I do, because it's... So that's going to return a Boolean. And for now, I'll just say false. My arguments are, so square is going to be... no, I don't want to pass it square. I want to pass it the key. So I want to pass it the key so that then I can calculate the x and y of the 8 locations around the square. So I think if I say this is square and it is a tuple of I32, and then hash map, so and then grid, which is a hash map of key is I32, and then it's a char, something like that. Oh, something's not happy. Syntax error expected. What have I done here? Where? Syntax error expected. Those should be there, shouldn't they? Oh, maybe not. Got all sorts of unhappiness going on. Dots. All sorts of unhappiness going on. Grid. Borrow of grid occurs here. Oh, right. Okay, so maybe I need to do that and that to... That's resolved some of the unhappiness. Oh, right. Okay, and this I think is just because I'm not using them. Yeah. Okay, cool. Okay, cool. Right, so I've got my square and my grid coming in. So my square is my square is really like my x and y. Yeah, I don't like the name square for this, but we'll go with it for now. And yeah, so squares. I'm thinking of like each of these is like a square, like square. So the squares I want to check that have a, let's go with a vec full of tuples. So we want to be checking square.0, square.1, but so we want to check above and below, and we want to check above adjacent and below to the left, and the same to the right. So it will be that. Oops. It will be that. And that. Oh no. Where are we going? No, I want this so I can see what I'm doing, please. You can make it nice in a minute. I want to see what I'm doing. And then we're going to need, so down. So this will be X. Hold on. This is all of these. Every time there's this X and Y, north, south, east, west. I get so confused. So this is checking. So on the X axis, we're in the middle, and we're checking above and below the X and Y of where we are. So if we've got this one, we're checking above and below it. We've got this one, we're checking above and below it. And now we need to check these other, there's 3 down this side and 3 down this side. So that's going to be, well, it's always going to be square.0. So it's going to be -1, isn't it? And then it's going to be square, square.1 plus 1 for above. And then it's going to be that, because we're on the same, we're on, that's right, because we're level, and then that's going to be underneath. And then these, I don't know whether I need to, but I'm just going to put, that's that. And then we're going to need all of this again. But this is going to be that. So that is effect. So what I'm getting in the current location, and then I'm creating, like, this is going to be very inefficient. I've just realized that this is going to be doing this on for every single character. I'm going to be creating this. So really I should create it up here and pass it in. Let's see. So then I need to, with this, what do I need to do? I need to, I'm counting dots. So I'm going to say dots equals squares dot iter. And then we'll fold. So we can count how many dots there are. So dots, so similar to what I had before, I think. Dots and then I want the, hold on. So that's my accumulator. And what am I getting in? I'm getting in a square, getting myself totally muddled with these very bad variable names. Not bad, but just, it really helps, doesn't it, if you name things, which is one of the big problems. But yeah, just really, really helps if you you know, you're not doing mental gymnastics over the names of your variables. So here I can say if grid, if grid.get, and then I can just pass in square, which is my X and Y, and then I was going to use is none or, and then here I'm going to say X is equal to a dot. If that is the case, then I'm going to say dots plus 1, else I'm going to return dots. And then I probably need to dereference here. Okay, yeah. And then here I can just do, I think, if all is good, I can do dots greater than 4. So if I've got more than 4 dots, I get true. If I've got less than 4 dots, I got false. And we need to have fewer than 4 rolls of paper, so in the 8 adjacent. So I think the maths is possibly right. And then here, oh, I've already, yeah. So that's okay, I think. So I think a lot of this is gonna rely on whether I've got this right. I always mess up this stuff. But I think, and then I'm returning, yeah. Well, no, I'm not returning dots here at all. What am I doing? I'm returning rows. If I found, oh my, rows. It's not dots at all. Here I'm returning rows, counting rows. Because if I found a roll, I'm getting mixed up with my dots and my rows. Not doing very well with differentiating between my variable names and what they mean. Anyway, right, let's have a look. No complaints from the compiler and Rust Analyzer. So let's have a look. Let's run the test. Let's clear. Well, that works. Okay, let's see how slow this is. Okay. I don't know what to make of that. That's, again, I'm surprised that nothing's blown up. But yeah, let's go for it. So 1419. Fingers crossed. Here we go. 5, 4, 3, 2, 1. Yes! My grid, my hash map. Boom. Even got all my working out the squares around the square. Right, chuff with that. Okay, well, yeah, nice one. Well, I think that's probably long enough for this video, so I'll chop it there and yeah, see you in the next one.